Thanks everyone for joining the interim so far. This is a pretty light crowd. I think we're missing even some of the obvious regulars. So if anybody knows why some important contributors are not here, or if you can bother some people and try to get them here, let's try to get as many people as we can before we get started. Tim?
Right. On that note, Chris Patton can't join us today because he's on vacation, and I also believe, I might be wrong, but I think Martin Thompson won't be here. I'm not sure why, presumably because of time zone issues.
It is then, but I suggest we go ahead and proceed. At 7 minutes after, I'm not sure anyone else is joining us today. Ben, you're muted.
Thank you. Tim, I think sorry, it's first order of business is to go through the chair slides here. So as a reminder, this is an IETF working group meeting. That means it's covered by the IETF Note Well, which creates certain obligations on you by participating in this meeting. If you're not familiar with those obligations, please leave the meeting and go review your obligations under the Note Well. It's important that you understand those before you participate in an IETF working group session. We also operate under a code of conduct and anti-harassment policy. I hope everybody is familiar with those as well. And if you do notice a violation of those policies, we also have mechanisms in place for you to report and redress those violations. This session is being recorded. This video is going to be posted to the internet for all to see, so be aware. And finally, our planned agenda for this meeting is primarily to talk through the latest updates to draft 15. That's our goal, is to make as much progress on that draft as we can. If we do have time, there have been some requests that have come in to discuss a couple of other drafts related to this working group. So if there is time and interest, then we can talk about those topics as well. Are there any concerns with this agenda? Anything that people would like to change? Cheng?
Hello, PPM. I remember I just sent an email to PPM requesting talk about draft of 1 PSI PPM. I wonder if the time is permitting.
Okay, thanks. We can also include that under the time permitting section.
Thanks.
All right. Excuse me. Thanks, Ben. So, good news to the other presenters is that I expect we will have plenty of time to get to everything else. This shouldn't take incredibly long. So, as Benjamin explained, I think what we're principally discussing today is what's the path to working group last call for distributed aggregation protocol. So, with that in mind, I'm going to cover what's been happening there since the last time that the last interim we had, which I think was in March. We're going to talk about like stuff that's in flight right now, both in terms of changes to the document, as well as sort of other procedural things that are going on. And I guess we'll take the room's temperature on what we should do next. All right, let's get into it. So yeah, Ben pointed out to me this morning, or it might have been Sam, this is wrong. This should be since like March 2024. So please forgive the error. Okay, so since the last interim, we released a new version of the draft, which is 15. And then we've actually been making some more changes beyond that. There's a full list of the pull requests that have been merged on GitHub, linked here on the slide. So we didn't expect 15 to be sort of the end or the final draft. The reason that we did that release actually was so that we would have something to hand off to the HTTP directorate for review, which I'll talk about a bit more later. So we were always expecting to have a little more work to do and to be releasing at least draft 16. Okay, so 15 contains the bulk of it by the size of the diff is a lot of editorial changes that we made with an eye towards clarity and concision. As you know, our hope as the editors is that the document is approaching completion. So now is the time to get really fussy about how things are spelled, word choices, the layout of the document. So we went and like audited the use of certain terms like, aggregate or batch to make sure that we're being consistent about them. We added some explanatory materials and some diagrams since a consistent piece of feedback that we've gotten over the couple of years we're working on this is that this whole thing can be rather daunting to people new to the subject. And with that in mind, also, we've done some like significant editing and reordering of the document so that the introductory and overview sections ease the reader into what this is all about before really deluging them with the very specific concepts and terms of the concrete interactions that make up the protocol. And there's a lot of stuff that I call out as ticky-tacky here on the slide, but does matter, I suppose. So for example, we have much stricter definitions of the various time-related types in the protocol. And here I should credit, I think, David Benjamin. We stole some text that David wrote for a draft that's going through TLS to be like excruciatingly precise about what is or is not a valid sort of interval of time or an absolute time. One wart that we're going to have to live with here, I think, is that we've changed the definitions of times such that in most places, or I think all places, times and durations that are not multiples of a task's time precision are invalid. So like all times must be aligned with or rounded to, depending how you prefer to think about it, a task time precision. So I wish now that we had defined times and durations such that the number that goes on the wire would be the multiple of the time precision, thus making invalid ones impossible to represent. But that's a more dramatic change than I want to make at this point. But I don't know. It's something that I'm going to keep in mind for maybe future protocols that I write. And what else? Yeah, we got, like I was saying, very fussy about things like how to properly cite other documents, or when we're using a URN versus I versus L, things like that. The more significant change in there in draft 15 was a family of changes around better alignment with RFC 9205, which is the BCP, providing guidance on how to build APIs on top of HTTP. And that entailed consistent asynchronous handling of requests across the aggregation, collection, and aggregate share interactions. So we discussed that extensively at the last interim, and the relevant PRs also have like a ton of discussion in them, which I don't really want to cover again here because it would take a long time. But all that landed, and I think it looks much better now. Okay, what else? Right, we got a very comprehensive review of the document from Eric Rescorla, which was really nice. And amongst other things, what that enabled us to remove the extensions to the RFC 8446 sort of structure syntax that we had to invent. So that's nice. That's a pretty dramatic simplification. Basically, we traded a few extra lines of explanatory text in the protocol definition for like several paragraphs of specification of this syntax that we had invented. So that's a win, I think. We also as a result of Ecker's review, we had to sync up with the most recent VDAF draft. So VDAF, I suppose it's worth mentioning, is also essentially final. I'm not certain, but I think the authors of that document think it's pretty well done. So one of the last things that they did was to update the API for the ping pong topology with an eye toward making illegal states impossible to represent. So DApp had to make some small changes to adopt the amended ping pong API. And also of interest, we did some very careful work on the input share and batch validation rules. So this is stuff like anti-replay, where a given report may only be aggregated into a single batch, or double collection, where you don't want to be counting reports twice, or the rules that govern when aggregators should or should not agree to aggregate a given batch. So this is some of the trickier stuff in the protocol, and thus we felt it was important to be very unambiguous about this, right? So we wanted to avoid stating requirements in multiple places, and wanted to avoid any ambiguities about like something being a may in one place or a must in another. So I think at least I think it's much better now, but it can be hard when you're so close to a document like this to get an accurate assessment of like whether it's actually clear. And finally, there was a somewhat interesting change where we provided some guidance on how to relax exactly those input share and batch validation rules. Eric Rescorla pointed out that there might be some scenarios where deployments want to make some trade-offs of privacy versus utility. So there's no changes there to the actual normative text of the protocol. Rather, I think we put this into security considerations. We just provided some guidance on like, well, you can relax this rule, but if you do, bear in mind these things. And there was some discussion also of how differential privacy can provide some protections, even if you do things like allow reports to be counted multiple times. Okay, and I think, besides the asynchronous interaction stuff, the biggest change in draft 15, no, excuse me, this is a change we made since draft 15, which was to allow bulk uploads. So the idea here at its simplest is we want to allow a single upload request to allow multiple reports to be transmitted at once. So where we landed here is the upload request message that you see illustrated, where it's pretty straightforward. Previously, this message would have had a single report in it, or in fact, the message was the report. Now it's an array of reports. So the particular use case that motivated this was the notion of proxies that might sit between many clients and the leader and would want to gather up a whole bunch of reports and then forward them along in a single HTTP request, as opposed to doing many of them. But one thing that's not obvious here, which we sort of iterated on a bunch as we did this change, was that the way that we have this array of reports here, there's no length prefix in the message. Rather, message length here has to be determined by the length of the enclosing HTTP message. So this could straightforwardly be the content length in an HTTP 1.1 message, but the intent here is to also allow for things like chunked encoding or HTTP2 streams. So what this enables is, this enables a client or a proxy that's sort of acting as a client to begin transmitting a long sequence of reports before it actually knows how many it's going to send. So this can be useful for basically for streaming reports into the leader, right, without having to accumulate potentially in memory like a large number of messages. So thanks go to Alex Koshelev for this contribution, and also Martin Thompson, who helped us get some of the sort of nuanced details of how to spell this properly in HTTP terms. Okay, so having done that for the upload side of things, it occurred to us, or in particular, Chris Patton pointed out, that we might want to do the same thing for the aggregation job messages in the protocol, which sort of have the same characteristic in that they principally consist of a long list of sort of per report messages, which could get quite long. So in particular of interest here are aggregation job init-rec, continue rec, and aggregation job resp, which serves as the helper's response to both of the previous messages. We also considered doing this for the collection job and aggregate share messages, but ultimately opted not to do that because while those latter two interactions do contain some variable length messages, they're not messages that have like content per report. So basically they won't vary quite as much, and there's less value in enabling a protocol participant to stream those messages over the network. So we decided just to do this for aggregation jobs. And yeah, so what the change would amount to is what we see illustrated here for the case of aggregation job init-rec, where previously prepare inits was a length prefixed vector of prepare init, with a length bound on it. So the idea there is that on the wire, you would have had, I forget, I think it's 4 bytes of length prefix before the vector to tell you how long it is. Now instead, it's sort of prepare init's length long, and the implementation is meant to figure out how long that array is by taking the overall HTTP message length and subtracting the length of the other fields in the message. So we haven't landed this change yet. There is a pull request up to do this. I believe it's number 717 linked in the title of the slide here. But I guess we wanted to get working group consensus on whether this is a good idea. I think it is principally for alignment across different facets, different interactions in the protocol. But we wanted to give the working group a chance to chime in and maybe say this is a good or bad idea. So I have one slide left, so I'm going to talk to that before I guess we open the queue and speak to this question and the rest of it. Okay, so that's what's been happening in draft 15 and what has happened since draft 15. And then I think what we ought to discuss is, well, what do we want to do? What else might we want to do before we consider taking this document to last call? So first off, we've got an outstanding review request with the HTTP Directorate. This was requested, I think, back in April. Was the date I saw when I looked at this the other day. We asked them to look at draft 15, which we had just cut off at the time. The HTTP Directorate hasn't gotten around to this yet. I think we should probably just have them skip ahead to 16 once we cut that draft, which shouldn't take incredibly long. Then we have a handful of remaining open issues on the document that we need to resolve one way or the other. So some of them are quite straightforward. There's one that we also have a PR up for, which is to do with, excuse me, disambiguating the handling of malformed times in a couple of cases. Basically, JC, who's with us today, pointed out there's an ambiguity where you could have a message that's malformed, and it wasn't clear whether it should be, what error code it ought to be rejected with. So we clean that up. And then there's sort of more procedural mechanical stuff. We gotta excuse me. There's a couple of registries in the document for carving out a little URN space for error types, as well as some identifiers for protocol objects. So we have to do some IANA stuff for that. And there's some document references to be updated. Like, for instance, once VDAF, hopefully if and when VDAF gets a RFC number, we want to update the references. There's others that don't have resolutions quite as obvious. We have a couple of issues open about adding some diagrams to the document, which is a little nebulous because it's not super clear to me, what diagrams, what would they illustrate? And there's another sort of question about aggregator storage, which I won't speak to because, to be honest, I don't completely understand the question. My thought on these is that, my personal opinion is that we could go ahead to working group last call, and if in that period of however many weeks it is, changes come in, like pull requests come in to address these issues, then great, we can review them and take them. If they don't, well, then I think we can simply close these issues, right? And if nobody opted to take action on them, then we can take that as evidence that the working group didn't feel that they were that important. Okay, what else? We should release draft 16, which, like I said, I think is what we ought to point our colleagues at the HTTP Directorate at for review. And of course, it'd be great to have an implementation. So we have bits and pieces of this done in Janus, which is ISRG DivvyUp's implementation. There's a tracking issue here for all of that. So I'm not sure if it would be wise to wait to declare working group last call until we have at least one working implementation, or if we're comfortable sort of doing those things in parallel. And of course, more reviews of the whole document or even parts of the document are always welcome. Like I said earlier, Ecker did a review of the document maybe a month or two ago now, and I think it was great, right? Like we got a whole bunch of issues out of it, which Chris Patton and I made a point of jumping on and addressing. So I bring that up as evidence that, like, despite how hopefully late it is in this document's sort of life cycle, we still very much do welcome feedback, criticism, suggestions about the document, and take them seriously, and we'll address them. So please do speak up about anything you think could be improved. Okay, that's all I have. I guess we can open the queue to talk about, let's see, perhaps we could start with this question. Does anybody have any opinions or feelings about whether we should enable streaming of these messages? Go ahead, Sam. Sorry, am I stepping on your chair?
No, you're fine. Go back to your last slide for just a sec. Which of these do you think are blocking for last call? Which have to be blocking?
Honestly, I think none of them. I think that my opinion is that all of these can come in. Okay, sorry. If we speculate, if we guess that last call would be held open for like 3 or 4 weeks, I think anything that needs to get done here could get done during last call. And in fact, Chris Patton did mention to me that he would like to do a whole document review of the sort that I was mentioning, but he'd be comfortable doing that in the span of last call. The only thing that maybe particularly concerns me is having an implementation. It would be really nice to have some code that proves that, like, we didn't break something, like, that we didn't make a change that is impossible to implement. But I'm sort of reluctant at this stage to, like, introduce blockers,
Thanks much. Feel free to go ahead.
Okay. So does anybody have any opinions about whether we should make the aggregation job interaction messages streamable? And I mean, it's perfectly all right to say, I don't know, and we can certainly pursue that discussion on GitHub since the pull request is still open.
Hi, Ben Schwartz. You mentioned that the goal here was to improve consistency. At least one of the goals was to improve consistency between the different kinds of messages. Does this leave us in a state where all the messages basically have this this form of relying on the HTTP transport for length, or are we still going to be in a mixed state where there are some messages with explicit lengths and some with implicit lengths?
It's going to leave us in a mixed state. However, there is a clear distinction between the messages where between these sort of families of messages. So in particular, you have the messages for collection jobs. That's where the collector requests a collection from the leader, and aggregate shares, which is the corresponding interaction between leader and helper. Those contain at least one length prefix vector. So, like, technically you could modify those messages so that one of the length prefixed vectors in them becomes I think 8446 calls these fixed length vectors. But Chris and I looked, like, I drafted that change. It's one of the commits in the history of the pull request 717. We decided not to do it. So the distinction of interest is like, would you want to stream these messages, right? So aggregation job init-rec, which we see illustrated here in particular, it grows linearly in the number of prepare inits. And you might conceivably want to stream this because maybe what your leader implementation is doing is, like, consulting your database, looking at like, okay, how many reports do I have to like prepare in this aggregation job? And you stream them out of the database, construct the message, and then send it along. Whereas the things that are in a collection job message, they're just not sort of amenable to streaming in that way. Like in particular, the variable length field in a collection job message is the aggregation parameter, which is not something that you would stream. It's something that an implementation would absolutely like know, you know, have in memory when it constructs that message.
Okay, thank you.
Okay, I'm not taking anybody else in the queue. So the resolution that I'm going to take away here is that, sorry, I'm inferring that you know, people probably need time to sort of read the issue, read the PR, and develop opinions. So I think how we resolve this is that I'm going to go ahead and merge pull request 717. Let's say end of day Friday, which is no, wait, that's the 4th. That's a holiday. Let's say Thursday, which is am I mixed up? Sorry, I'm looking at my calendar. Yeah, okay. I'm going to merge that change end of day Thursday, which is July 3rd. Unless you know somebody speaks up in the pull request to suggest something else. Okay, so then flipping back to this one, which is besides the things enumerated here, does anybody think there's anything else we should get done before last call? And that's either before sort of announcing last call or before concluding it. In particular, I'd like to hear opinions about whether we should wait until we have an implementation to prove this out. Deb, go ahead, please.
Yeah, so the trick is you're going to have working group last call. You're going to have somebody writing a shepherd's write-up. You're going to have some AD, I don't know who that would be, reading 100 pages, which she's never read before, right? And then you're going to have IETF last call. So I don't think you're, in my opinion, my perhaps uninformed opinion, I don't think you have to have your implementation on the street before the end of working group last call. I think you need it sort of there or thereabouts in the IETF last call timeframe. So I think you have time. I don't think in general it's wise to wait around if you think the draft is in good shape before you start the publication process, just because people tend to move on to other things and they forget where they were, and sort of the tighter we can keep it moving along, the better off you are sometimes. That's just my opinion.
I think maybe the one thing that's not mentioned here is the question of the status of VDAF. Are we confident that the VDAF draft is not going to evolve in ways that would significantly change the text here?
Yeah, that's an excellent question. It certainly is a dependency. So yeah, my understanding, excuse me, I'm scrolling through the CFRG list trying to find the last thing that was said about VDAF. My understanding is that the authors of VDAF like consider it pretty well done, and I seem to recall them asking CFRG chair. I shouldn't talk out of school here. David, since you're with us today, David's one of the editors, one of the authors of VDAF. I don't know if you want to speak to like whether VDAF is making its way, where VDAF is at in CFRG.
Yeah, I think as far as DAP is concerned, we're not expecting any further changes that would impact how we use it. Yeah, I forget exactly where we are in the process, but we're trying to move it along. And I think the last thing might have been asking for crypto panel review.
Yeah, that's where it is.
Okay. That's what I got.
Yeah, I wasn't sure if there had been a research group last call for VDAF, but it's waiting for crypto panel review.
Okay, thank you. Tim, is there anything else you wanted to mention in this section?
No, I believe that's it.
All right. Well, we have plenty of time blocked off. So if there are other topics relevant to PPM that people would like to bring up, this is a fine time. I see Cheng has hand up first, so let's start there.
Thanks. Let me check if I can share my slide. Excuse me, but I've never used this website before. How can I share my slide?
Don't feel bad about this. It's a weird website. It's working. Eventually.
Could I upload the slide from my computer?
They have to be
No?
shared from the meeting materials.
Okay, so
site. They have
I
to be
just
uploaded
share my
to there.
screen. Sorry. Is my screen correctly shared?
I don't see it.
Tablet slide title. So it asked me to select 2 slides, but can I share my screen?
Yes,
I
it should be
think
possible to do a screen share.
it's the third button. The slides is 4th. You want the 3rd one for share screen.
Yes. On third button, already click the third button, seems, and there's the green hand on it. Seems my screen share has to be approved before the screen is shared.
Yes, I'm not seeing those approval messages coming to me. Sam, do you see them?
I'm seeing the pop-up, and I'm not seeing a way to approve it.
Yeah, that's a surprising behavior.
So, Ching, if you can, do you know how to upload materials for the meeting?
How can I upload the material from? I didn't find any button.
I will try and send you a text message. Maybe Tim, maybe Ben, we should go on to the other 3.
Let's flip the order here. We'll come back to
Yes.
this when we resolve technical difficulties. David, do you want to?
And Ching, I'll post a link to how
jump
to
in.
upload.
Sure, can do. All right, so this can be a very brief update. This is about the draft Thompson PPM L1 bound sum. So this was originally introduced by Martin Thompson at the October 2024 interim meeting, so 2 meetings ago. As a reminder, this draft defines a pre-O3 instance for vectors of integers where the sum of the vector elements is less than some limit. This VDAF shares some features with pre-O3 SumVec, as well as pre-O3 multi-hotvec, plus it makes some different decisions along the way. This works well with differential privacy noise that uses the Laplace distribution, so exact differential privacy. And one other nice feature is it does allow for a 0 measurement. So the main update is that since we last discussed the draft, we've fleshed out the specification. This is now draft 01 on the data tracker. And we've written a reference implementation and produced some test vectors following the usual VDAF test vector format. So that's where we're at right now. It's, I think, ready to go. The next step is production implementation and getting it deployed. But with that, happy to answer any questions, and I'm also curious to know if there's interest, at least into the attendees, for adopting this in the working group. Thanks.
Tim, go ahead.
Yeah, hi. So I'm interested, though. I mean, I don't know. I work with David, so I suppose that's obvious. But more to the point, we're planning to do an implementation. So I believe David and Martin, or principally David, already have a Python reference implementation that goes with the draft. We're planning to do a Rust one as well.
Hey, so my question for you, David, is do you view this as something that is essentially similar to the PRIO development work, which happened in CFRG and should go there, or do you view this as protocol development that would happen in the IETF?
Yeah, I think this was discussed a little bit in October 2024 meeting. So this is not really crypto per se, because all this is doing is defining, well, the term in the VDAF is the aggregatable, affine aggregatable encoding and the validity circuit. So this is like pretty straightforward, just like an arithmetic circuit. I think it probably doesn't rise to the level of crypto that where it would necessarily need to be in CFRG. And I think PPM might be a good place for it, since it's certainly relevant to the people in this group, and it's mainly just defining a new sort of measurement encoding and so on.
Thank you. Tim?
Thanks. Yeah, I got back in queue to speak to the CFRG question. So I also strongly think we should adopt this in the PPM working group for all the reasons David said. Additionally, I think our experience with VDAF is that exactly the same people who end up looking at this stuff at CFRG, the people who contributed to VDAF at CFRG and looked at it are people who were in PPM anyway. So you're getting the same eyes here as you would over there. Further, I've spoken about this kind of thing to CFRG chairs, Nick Sullivan in particular, before, and they agreed that like PPM is probably a better venue for work like this than CFRG. So I think it's vastly more expedient for us to do this work here.
Okay, thank you. Benjamin Case?
Oh yeah, just jumping on the queue to just +1 that support interest in adopting this in the working group. And obviously we work with Martin on this kind of functionality to be supported by DAP. But to me, it seems like a very natural thing to kind of add on to the work that this group is already doing as another one of the proofs that is supported. So just +1 of that.
Okay, thank you.
Thank you.
All right, that seems like we've drained the queue on that one. Cheng, do you want to try a slideshow again?
Yes, I uploaded the slide on the website, and it says waiting for approval. Then I can select it from the slides, I think.
Okay.
Waiting chair approval, it said.
I clicked the button. It's a PowerPoint, so hopefully it will work.
Yeah, it's in finally. Yeah, thanks for waiting and thanks for the help. Hello, PPM. This is Chen from Ant Group. Ant Group is an affiliated company of Alibaba Group focusing on financial technologies. Today, I'm going to share you a slide about privacy-preserving computation, use cases, and problem statements. This is to provide a context for our previous draft 1 PPM PSI, as we received several feedbacks about the motivation and the use cases for PSI after our previous talk. As we all know, data is the most valuable resource for information business. Nowadays, the success of AI is directly related to the growing size of data on the internet. However, as a report shown by The Economist, it is quite possible that in several years, all useful data on the internet will be exhausted. For example, it is now 2025, and the Llama 3 and the Grok 3 are already using about 10 trillion tokens on the internet. Actually, as experts estimated, there are only about 1,000 trillion useful information on the internet currently. As a result, if this trend still goes, in about 3 or 5 years, the companies will be using up all the available data on the internet. At that time, all the data will be at the same amount of, used by the companies, and they will be at the same starting point. So we estimate that at that time, the proprietary data will be the next blue ocean. For example, the financial data, for example, who are selling and buying the stocks, this information are only known to the stock exchanges. And health data, who are using what medicine for health issues, this information only known to the hospitals and pharma companies. If these companies can cooperate with each other, they can make better decisions than fully on their own. So we estimate that one who can combine those proprietary data will likely build more successful business than their competitors. Of course, because those data are their business secrets, it's better to be done in a secure and private way. The first example use case, which we have presented before, is the data set intersection across companies. The two companies, A and B, wants to find their mutual customers. If they can find those mutual customers, they can establish some joint marketing campaign. For example, suppose Twitter and a game company like Electronic Arts, they want to find how many people who both tweet a lot and like video games a lot. Then, if there's a large number of such people, Twitter can pop up some advertisement for them, and they will have a high chance to be clicked. However, during such collaboration, Twitter's own customer information and Electronic Arts customer information should not be revealed to each other. They only want to know the percent of people who should be reviewed. That is one kind of the private set intersection problem. Now, let's dive a little deeper and see how such PSI could be done. A straightforward idea is to let party A hash his own data and send the hash values to the other. But such method is not secure because the PID, such as telephone number, it usually does not have enough entropy. For example, there are only 8 or 7 digits. Hashing values without enough entropy is equal to sending the values in plain text. One can simply hash all the values from 0 to 9, and we will get all the original values of the hash values. So we need some specific cryptography protocols. Actually, researchers nowadays have already presented many secure PSI protocols, some based on Diffie-Hellman, oblivious transfer, and vectorized oblivious linear evaluation, VOLE. They each have their own pros and cons. Among these methods, the Diffie-Hellman based is mature and has acceptable efficiency and has already widely been deployed by many companies, at least as far as I know, in many companies in China. It's widely used in use cases such as fraud detection, credit card activation, and coupons issues. Let's talk about an example use case which I was in charge of. The Youku, which was thought to be a Chinese version of YouTube, and the Weibo, which was a Chinese version of Twitter, they each have about 1 billion user PIDs. They want to find out their set intersections. We wrote the ECDH-based PSI program, and they successfully ran PSI in about half a day. Based on the PSI output, the leaders of the two companies made some really important business decisions. And the second use case is a private key value query. There is a server and a client. The server has a large key value database, and the client wants to query about the value of a certain key he is interested in. But he does not want to let the server know what is the key he's querying. This usually happens in sensitive queries such as credit or health queries. Let's suppose a small company wants to query a user's credit. And based on the credit, he can make some useful decisions, but he does not have such a complete credit database. Company A has such a credit database, so B wants to query from A. But the query ID is very important because suppose I am querying about my credit, it might imply that I want to apply for something, such as applying for a loan. It is very important because if it was known to other companies may intercept and offer the loan to me instead of B. So B does not want to let anyone know he is querying about my information. Suppose there are two database services. One of the database offers a private query API, and the other database does not have. Then we can be sure that the former service will be much more competitive. Okay, let's see how such private query could be done. At first glance, such method is impossible because whichever row is returned, the database inevitably learns the row ID, right? But fully homomorphic encryption could make the query possible. Let's see how it could be done. Step 1, A has a key value database that is several points on the 2D diagram. He can make an interpolation and obtain a polynomial. For example, there are 100 points, he can make a 99-degree polynomial. After the polynomial is made, then A can throw away the database. The polynomial is the database, right? If you want to query ID, just apply the polynomial function to the ID, then he obtains the value. So B can send the homomorphic encrypted key to A, then A homomorphically computes the function f on the encrypted key and obtains the encrypted value. During the whole process, A does not know what key is being queried. It only knows that a function is being evaluated on an encrypted query. So our goal is achieved. Of course, the real deployment is much more complex because we have to apply several optimizations. First, we have to lower the multiplication depth. Otherwise, suppose 1 million points, we need a 1 million minus 1 degree polynomial, which is not practical, right? So we have to make the solution acceptable and more efficient, such as batch queries and computation trade-offs. Here's another example that we encountered in Alibaba Health. That is a secure medicine search. We know that if we search some medicines on the web, it implies that there may be some issues about my health condition. So it leads to some privacy leakage. So Alibaba Health wants to build a medicine search citizen that can completely hide what medicine I am searching. So there are about 100 million medicines in the database. It was nearly impractical for private queries using homomorphic encryption. It's very slow. So we split the database into several groups, say 100 groups. each group will use a different interpolation function, and the client has to clearly state which group he is querying. So the group ID may be leaked, but that may be acceptable because in that group, there's still 1 million medicines. The server still have no idea which medicine is being queried. Finally, we build a system that can querying 1 million medicines in about 5 seconds, which is not very fast, but acceptable for a private system. And the third use case is a private inner product. A holds a vector, B holds a vector. They want to securely compute the inner product without leaking the vector raw value. This is quite useful in customer similarity because inner product is just a cosine similarity, right? Such as finding relatives based on genes and matching the fingerprints that all can be computed by inner products. Here's another example that we encountered. Suppose a small bank B, he wants to evaluate its customers' credits, but he has no such a powerful model because he is just a small bank. And another big bank A has a successful model that can predict the credit based on income each month. So B wants to seek help from A, but he does not want to leak the income of his customers. So B sends encrypted incomes to A, and A computes the function, the model, on the encrypted income. Suppose it's a linear model, then the inner product is enough. Then he computes the encrypted sums, and B decrypts, and it knows the credit, what the credit was, and can make the business decisions. We optimize the system and use the Pioneer homomorphic encryption algorithm, and finally we can achieve about 100 milliseconds per query. And the fourth use case is about a little big. It is about a collaborative machine learning. Two companies each have some data, and they want to jointly train a machine learning model on the joint data. But neither A nor B wants to directly share their data with each other. It is very useful in fraud detection and credit assessment and recommendation systems. For example, there's a use case between Chinese Amazon, which is Tmall, and the Chinese Verizon, which is Chinese Unicom. They want to find, I suppose, the Chinese Verizon finds some potential fraud users, but he's not very sure. He wants to make sure that whether they are real potential, real fraud users under the help of A. So step 1, they each clean their data set. And step 2, they do a PSI to align the data set according to some IDs. And finally, after the database are aligned, they can use MPC, which is secure multi-party computation, to run a decision tree-based training. And we successfully built a system that can train a model on 10 million users with 10 features each in less than 1 day. Our algorithm is published on Usenet Security 2003. And by using this, the company B successfully find whether the users are real fraud users. Let's make a summary. We are interested in the problems where a few data owners, usually 2 or 3, they want to collaboratively run a function on their joint input. But they want to make sure that nothing is leaked beyond the output they negotiated. And the output is only accessible to the authorized party. For example, only party 1 should know the result. There are some requirements for security. Interestingly, we often semiotic security is enough because the parties in these use cases are not randomly picked. They are companies that already have some incentive to collaborate. So rationally, they won't do malicious behaviors because that will harm their reputation. For functionalities, we require the solutions to support the frequent tasks used in business scenarios. And we often need to align the APIs and make them easy to use for non-cryptography users. For performance, ideally, we want them to make best use of available computation power and minimize the communication size and the communication round. But in practice, we often have to make a trade-off, which comes first. So since all of these use cases are very common and useful in internet businesses, we suggest commencing research and standardization efforts on these privacy-preserving computations for cross-company collaborations. As a start, we suppose to standardize the PSI first, because PSI is the very beginning of all these algorithms. Before the companies want to collaborate, they usually run a PSI to decide whether they want to collaborate and what kind of business they want to collaborate. So PSI is a good start, and it is simple. Here are some ongoing researches. Some are from our team and some from related works. Okay, thank you. I hope the continuous support for our PPM 1 draft on PSI, and I'm open to any questions. Thank you.
Thanks for this talk. So my first question is, focusing in on the ECDH private set intersection stuff. Since it says elliptic curve in the name, I'm just curious, what's the post-quantum story there, or is there one?
We suggest to use the 25519, which is very fast, and we also are open to other curve IDs, because different companies or organizations may have their own preferred ecliptic IDs.
Right. I might be stepping outside of my comfort zone here, though, but like, my understanding is that regardless of which curve is used, in the face of a cryptographically relevant post-quantum, quantum computer, excuse me, elliptic EC in general, like, won't hold up, right? So obviously this isn't a thing where we have to worry about like harvest now, decrypt later, but eventually there has to be a post-quantum set intersection story here, right? Or so is the idea that we would do this like for now and then eventually do something completely different, or do something completely different for post-quantum resilience, or is there a path in mind here?
Yes, there are indeed some researches on PSI that are robust to quantum computers. For now, the ECDH one is not, but it is fast and efficient. Our algorithm and protocols are open up to follow up post-quantum versions. We are hoping that we can are compatible to those algorithms.
Yeah, that makes sense. Maybe we'd be able to design something such that you could swap out EC for something. Yeah, cool. All right. Sorry, I'm looking at my notes. Oh yeah, so you also explained, and this will be farther out, doing private key value queries using fully homomorphic encryption. So I found that interesting, right? Because I mean, in my mind, the typical setting for FHE is where like the entity that's running the server doesn't want to see the data. But I'm curious, in the deployments that you're sort of describing here, doesn't the server that's running the queries like have the data in the clear anyway? Because say
yes, because the data is his. He just does not want to know the query, so the query is encrypted.
Yeah. So so in order to like run this FHE system, the like company that holds the data would have to then sort of transform the data into like an FHE form, and then would be able to take queries against it, right?
But yes, it just encoding the plain text onto the coefficient of some polynomials.
All right. And then again, possibly a naive question. In this setting, how does it compare to doing an oblivious transfer?
Oblivious transfer usually does not care about communication. So using oblivious transfer to do key queries will cost a lot of communication. But FHE will be very compact, but instead it will trade for more computation.
That makes a lot of sense. Cool. All right. Last question. This might be a little bit too big and nebulous. It was very illuminating to me. You put the focus on the one use case for this being enabling model training for generative AI, which I hadn't really thought about before. Now, that's also a field that I don't really work in, but it seems like the emerging popular solution for AI vendors to like share data is this model context protocol, which is being developed. I couldn't tell you exactly how. I think it's sort of happening informally in like GitHub repositories or something like that. Anyway, so what we're talking about here is a family of protocols that would enable, collaborative model training. Like, do we envision this as, in some sense, competing with MCP or possibly fitting into it somehow? Or do you have any thoughts on that?
I think MCP is just as inference time. We collaborative training is focused on the training time. Maybe it's a little different.
Okay, that makes sense too.
Thanks.
Cool. That's all I had. Thanks. This seems neat. And sorry, I see there's other people in the queue, so I will just say this work makes sense to me. ECDH PSI in particular seems appropriate for this group. I think that there's questions about what parts would be appropriate for CFRG, though I believe you and your co-authors have already taken some of this, like talked about some of this work there as well. But otherwise, I don't know, this seems to be, assuming that there is in fact interest from people to deploy this, this seems appropriate for PPM in my opinion. Thanks.
Yeah, thanks.
Hi. So yeah, thanks for the great overview. I do feel like I understand now the motivation and background definitely better. I don't think that this kind of work fits within the PPM charter as written. The PPM charter is pretty specific about developing protocols that compute aggregate values and support client submission of individual measurements, which is not really the architecture that we're talking about here. So I think really the word measurement in privacy preserving measurement for this working group refers to something pretty specific. It refers to computation of aggregate statistics over measurements or over inputs submitted by a very large number of individuals.
Yeah, such as DIP, I know it's just like a company wants to aggregate the information on its own customers. It's not related to another company. It's like this scenario.
Yeah, so I think I would want to take a close look at the charter and see if there's some way that I'm not seeing that we would frame this work in a way that would fit with the existing charter. Otherwise, we would be talking about a recharter or a separate working group. I think, if we were moving in a direction like that, I think the critical factor would be to see interest from multiple companies, basically multiple groups who want to interoperate with each other and find that difficult in the absence of a standard. That's the point at which a standard becomes necessary.
Yeah, anyway, thanks for the clarification.
I do think, as Tim has said, there's clearly significant interest in these technologies. It seems like some of the specific technical proposals that you've made are being well received. So I think that if you're interested in pursuing IETF standardization, there's probably some kind of pathway that could work. The one other suggestion I want to give you to think about is in DAP, the proposal has a protocol framework that is separable from the specific use case and cryptography. And so I think there's an interesting question for you about what how general the protocol framework ought to be that you're developing. Do you want a protocol framework for private set intersection, or do you maybe want an even more general framework that is about this kind of multi-party data fusion, regardless of the precise kind of fusion that is happening? I think that's
ideally there will emerge a set of drafts based on PSI. Each kind of data analysis will have its own protocol, maybe.
Right. So in the case of DAP, what we ended up with is a general framework for computing aggregates, and then separate cryptography that can be used to compute very different kinds of aggregates within this framework. And so similarly, you can, I think, imagine a protocol framework that allows combination of data between 2 or 3 different participating data owners, and leaves and then actually potentially leaves the question of what it means to combine that data to a second layer on top of the framework.
Yeah, we'll rethink how to put the position of such collaboration.
But that kind of generalization isn't, for DAP also hasn't been a free lunch, and there's been some cases where that hasn't worked out as expected, and DAP has changed over time. So I think there are some lessons, but there's no one answer.
Thanks. Hello, Ken.
Yeah, okay. Yeah, thank you, Chen. I really liked your presentation. There is a lot of use case for this kind of work, federated learning, and yeah. So, and it's like this. It's a hybrid. I think there will be multiple areas that will be covered, because there is a homomorphic encryption, secure multi-party competition. So I think, or maybe another group too. You can also form another group and like share the slides too. So because there will be a lot of what's it called, foundational knowledge that you will combine to build that stuff and improve that federated secure party computation or federated learning system you described. So I think, yeah, a new group maybe nice to form. Share your slide, please, after. Thank you.
Yeah, thanks. So I think I'm done. Do we have any other presentations?
That is all the working group business that I'm aware of. Is there anybody else who wanted to add anything else before we close out this meeting?
The Draftly homomorphic encryption draft, I think, was on the if time permits. I don't think we have any of those authors here.
Yeah.
Ken, you're asking to share slides?
Kenneth, I've attempted to pass you slides control since you appeared to be requesting it. Could you tell us what that's about?
So I was trying to just seek out the slide Chen just presented, so because I didn't have access to it.
Okay.
The one from Alibaba. That's what I meant.
Okay, you can find those slides for reference in the IETF data tracker.
Oh, okay. Thank you so much.
They're under the
I put-
PPM meeting materials.
Right, and I just posted a link to the page about the meeting that has those slides.
Okay, thanks.
You're welcome. Any other business?
Okay, I think we're done with this meeting. Thanks everybody for joining and for the great conversation. And hopefully we can use this to make some more progress toward closing out DAP and moving on to new interesting topics in PPM.